Sometimes you will see unbraced, that is also the same thing.
Meaning?
Unbraced.
What's it?
Unbraced or unbraced means not supported.
Okay.
Means the distance between the two supports. Okay. 20 feet. Both ends are pinned. Okay. So both ends are pinned.
Yeah, equal
The
one.
value of K will be 1. Very simple. Right. So first we calculate the value of K here. K is 1 and 20 multiplied by 12, which is
1 to 3
into it. Right. R minimum. How will you get the value of R minimum?
That's a sheet.
From the data sheet. Section is given W14 by 74.
Yes.
So find the minimum value of R. Now you already know how to find the value of R from the data sheet. Rx, Ry, and whichever is minimum, you will note down, okay, 2.48 from Rx and Ry values. Now you can calculate this KL by R.
Yes.
Because in the denominator you will put minimum value, so this whole thing will be KL by R maximum. 240 by 2.48, and this gives you 96.77. So this is less than 200. Okay. So pi square EI will be
Why 200?
this is that condition. Okay. For long and short. You see the previous slide also, you have seen the previous slide. Yes, yes. See here.
Isn't that same ratio?
Yeah. See here. Okay. Yes. For the application of those cases. So we apply here F is equal to pi square E over K L by R square, and that comes out to be how much? This is 29,000 KSI.
Modulus velocity.
Modulus velocity. And K L by R, we have calculated here. And 96.77.
The modulus is given, is it?
Huh?
The modulus.
Yeah, modulus velocity will be given in the data sheet. 39,000, same KSI. In the data sheet. E.
For the section?
Huh?
For the section?
Modulus velocity is not depending on the section.
No, here.
Yes. E value is same. Whatever be the steel grade.
Okay.
Okay, E value will be same. 29,000 PSI. Or in terms of SI units, 200 GPa. Right?
Yes.
200 GPa. Not grade point average. GPa. What is the meaning of GPa? GPa. Gigapascal. G stands for giga. Okay. So this value we have got here. Once we get the value of Fe, now you will decide which formula I should use. Then compare with this. 0.44 Fy is equal to 15.84. Now your Fe, which is this, is greater than 0.44 Fy.
Use that.
Therefore, use equation number 3.2, which is
It's 10-1.
the equation. This equation 3.2, this is equation 3.3. Right? So we decide based on this condition.
Yes.
Okay. Anyone you can use either this or this value.
Which there is just one.
Yes, whichever. Anyway, you have to calculate the value of F. Now, so we decide that we will be using equation 3.2, not 3.3. We come to this equation. F critical is equal to 0.658, and this value Fy upon Fe. Now Fy you will use according to this number, 36 steel grade.
Yes.
Okay? And then Fe you have just now calculated, 30.56, which is Euler's law. And you can see here, its Fy value was 36, but it is failing at 30.56, which is less than this number.
It should be less.
It will be less.
It should be less.
It will be less, yes.
Oh.
Yes. It also depends on this value, KL by R.
If it was more, do you consider it as
Short.
short?
So FCR is this, and then you substitute the values Fy and Fe, all these values multiplied by Fy here, and you get this value as 21.99. Okay? So critical stress for this column will be considered as 21.99, even less than this. Steel grade 36, but critical stress just 21.9, which is much lower than that value. If somebody will take this value, then definitely it will be on the lower side and the building will fail. See the difference between this 21.99 and 30. If somebody will calculate based on this Euler's formula, he will be getting 30.56. Okay, my building will be safe up to this. But actually, by experimental results, they found that that's why they developed this. You have only nearly 22. Okay. It will not reach at 30.56. So that's why we have to be careful when we are designing the columns. Now, phi CPN you can calculate. We take a factor of safety of 0.9, and this is your value of FCR, critical stress multiplied by the gross area. Gross area you will take from the data sheet, and that is 433.44. Okay. So this way you can complete this question. We will solve one question for practice. And here there are some tables also which are available in your data sheet. In some situations, like in case of your design project or in your design offices, when you will go, you can also use those tables. I will tell you how you can use those tables, where you can get these values of phi C FCR. Now see this type of tables also. So this is one way. This is one method which is based on this, because these tables are limited. These tables are limited. For some cases you may get these tables, okay, not for all. And also there is one thing that you will be doing, interpolation, right? Those who have studied numerical method, they will find it, but those who have not studied, I will explain what is that interpolation. Linear interpolation only, which is just like a straight line formula. Okay. So see here, this is the table which you will need to find those here. Available critical stresses for compression members for different steel grades. First of all, this is depending on the steel grade. Here 35, FY 36, 42, 46, 50. For these steel grades. Okay. And here you have the value of KL by R in this column. This is the value for phi C FCR. This green is for allowable stress design, which you are not using. You will be using this blue. Blue is for LRFD. Okay. Don't take that very, because here it is written already LRFD. This is allowable stress design, so this is different.
LRFD refers to what?
Yeah. LRFD stands for what? Yes. You tell me now.
I forgot it, sir.
No. I will give you -1. LRFD. Yes. No, don't go back. He will tell. Yes. LRFD.
Length ratio factor design.
Yes.
Length ratio.
Okay, D is design.
And F is factor.
F is factor, very good.
Okay.
L and R.
Length ratio, lateral
Huh?
ratio. R is ratio.
Tafi.
Load resistant factor design.
The resistance.
Always you will need the load when you are designing.
Okay.
And resistance of the material, that means the strength of the material. That is known as resistance. So load and resistance factor design. LRF. Many times it was mentioned in the first chapter and previous chapter also, when I was talking about this design of voltage connection, design of tension, has got LRFD. Now I hope you will not forget.
Right, sir.
Sir, what is LRFD?
By
Yes, what is LRFD?
I'm not
This is the problem.
load resistant.
This is the problem. Okay, I cannot solve this problem. Just now explained your friends, myself also, in full words, again and again. Okay. Yes. Muhammad Al Faiz. Yes. LRMD. What is LRMD?
Load resistance factor
Design.
design.
Right? Yes.
Design.
Okay. So you will be using this column, not this ASD, which is allowable stand design, which is obsolete. People are not using this method. Those who might have developed their literature review in the design project 1, they write all these things, LRFD or what is allowable stand design. Different approaches are there, but this is not being used. So here, this column which is blue color LRFD you will be using to find the value of phi CFCR, because we need this value for our calculation, either by using that formula which you have seen or from this table. But I told you that this table has the limitation that only for these spaces you can get the value from the chapter. Also here KL by R 81, 82, 83 like this, a difference of this. Now if the value is not exactly this 90, if it is somewhere between 91 and 92, how will you take the value of phi CFCR? Because at 90 it is this value, at 91 it is this value. You will not take average. If it is exactly at the center, then you can take average. If it is 91.3, you cannot take average. If it is 91.5, okay, you can take average. Because this is your linear interpolation. Like this. Here, you have some value, and if you see here, the values are given here. This is suppose, okay, I will take the same value and see what was the value in this case for L by R. Yes, 96.77. Okay. Now when we go to that table and see 96.7 is not appearing anywhere. 96.77. We have 96 and 97. So 96.77 is our requirement. L by R. But we don't find 96.77 anywhere. So 0.77 and this is 97. So that much difference. So you have 96. At 96 the value is how much?
19.9.
19.9 at 96, and at 97 the value is 13. Huh? No. For steel grade 36?
Is 36. 19.9 and 19.7.
Okay. 19.9, first you highlight this, 19.9 and 19.7.
7.
When the L by R value will increase, the value will be decreasing here. Or you can say, you can make a curve like this. Okay. Here is 96. At 96 you will get 19.9, and at 96.77 you will get the value of 19.7. Okay, this will be much better. So you see here, when the KL by R value is increasing, phi CFCR value is decreasing, and that we know very well from the previous calculation that if slenderness ratio is increasing, its critical stress will decrease.
97 there, not
Huh?
96.7.
19 point?
Here at
97.
down.
Huh?
Euro put it 96.77, it should be 90. At the right.
Right. See the right.
97. 97. 97. Okay. So our requirement is 96.77. So 96.77 will be somewhere in between. Okay, maybe here. This is your 96.77, and the distance between this and this will be 0.77. Right?
Yes.
So our objective is to find this value. How much is this value? How many of you have finished your numerical methods? Huh? You finished numerical methods or doing now?
No.
Finished? Okay. So how will you find this value? By linear interpolation. Huh?
Divide this shape
Yes.
to a triangle and rectangle.
Triangle. Yes. Like this, you can say that this distance you should find here. How much is this difference? That difference is just 0.2. Okay. So you have that difference 0.2 here, and this is 1 only. This is 1 because all these values are given as one difference. 19.6, 96.7 or 97, 98, 99 like this, these values. So we are interested to find this value. So in that case, just check how much is this distance. Here, if I draw a line, this value will be same 19.7. Right? If I add this number in 19.7, I will get this value. Okay? From this triangle. This is 19.7. So here, 19.7. Because I have drawn this line.
Yes, sir.
19.7. So in this 19.7, if I add this value, maybe this is y, then I will get the required number. And how will you find this value? This is very easy. This is your similar triangle. One triangle is here and another triangle here. With the help of similar triangles, you can say that okay, this distance is the distance between this value and this value. How much is this now?
0.2.
0.2. Okay. That value you see from the data sheet. 0.2 is the distance. Okay. And this is your distance,
1.
which is from this value, from here, from the higher value. How much? 0. This was how much? In our case, 96.77. So this distance is 0.77.
77.
And from here, this distance will be 0.23.
3. 32.
0.23. Right? This distance 0.23. So from here you can say that if I write this value 0.2 upon 1, right? This big triangle.
Yes.
Here, big triangle 0.2 upon 1 will
Equal.
be equal to y upon
0.23.
0.23.
2 will get y and then add it to
Yes.
19.
So you will get the value of y as 0.2 into 0.23. Once you get the value of this y, you will add it here and get this number. Okay. This is your simple linear interpolation. Right? So these values you will see from the data sheet, find the difference, how much is the difference. So that difference you will put here. Multiplied by the difference of your cylinder ratio with the highest number, because that will be decreasing. So in that case we take this value 0.23 and this is how much?
0.046.
0.046. So you will add the value here in this number 0.046 and that will be 19.7 plus 0.046. So you will get 19.7046.
It's hard. There is another way here.
Oh, which one? Yes, yes, yes.
Divide. Divide.
Divide?
Yes.
Divide from where?
We have 0.2 between the two values.
Okay.
Okay. Divide it by 100.
Divide by 100.
Yes.
Okay.
And multiply by 77.
Divide by 100.
Yes. And this is the 1% increment ratio. And multiply by 77 to get the values. The value.
Multiplied by 77.
Yes.
This number?
Yes. I
You're
did
saying
same.
0.77 is this number.
Yes.
Okay. And
I divide the 0.2 by 100.
you divide 0.2 by 100.
Yes.
Okay.
This is the 1%.
Okay. Then
And I want 77%. Multiply by 77.
means you are calculating the slope.
Yes.
In that way also, yes.
Two equation.
That way also you can calculate, yes.
You draw.
You see the slope. I'm just telling in terms of those because they have studied interpolation. Okay, yeah. So in that case, because it is written in the book interpolation. Interpolation. Because sometimes the people will do this linear interpolation for simplicity, but actually it is not a straight line. Actually, it is not a straight line. Just for simplicity in your calculation, you are considering linear interpolation. But this will not be a straight line curve. When you plot that curve, the curve will not be a straight line.
Between two values it will be
We assume that it for small interval, the value can be considered as a straight line. Small interval. Okay. But for more precise, you will take that curve. If somebody is doing finite element analysis or these things, then you can. So that way, either you use that slope, how much is the decrease in the slope, and then based on that, you will find that value and then get. So both ways you can calculate. So once we get this value, we will come to that.
Doctor, what is the final answer here?
Final answer here.
19.7.
Calculate here the value. Okay. You find this value and put here 19.706. Because you get this value 0.046. Why? And we come here.
0.046 is
0.046 is this value of y. Here.
no, it's not correct. It's
Huh?
I said 0.46. It's when multiply 0.2
Ah.
and 0.23. It's equal 0.4.
0.23 into 0.2.
Yes, this will come
0.046.
Yes.
Okay, so this 0. This value.
So the y is equal 1.
This y is equal to this much. We are calculating this value of y.
So it's equal 1.
Why it is 1?
Because the upper equation is equal 0.046.
Where is 0.046? 0.046 is only this much.
Okay.
0.046 is only this much. Now we find this value, this total value, which will be 19.7 plus this
No,
one.
I thought the line is divided.
Yeah.
No. That's fine. So now so we get this value and then phi c FCR. So that value you can.
The first one is easier.
So 19.7. When you add this number 19.746, not 046. 19.746.
No.
Okay. 19.746, and that value can be given. So that's why this value will be always an approximate value, not exactly the same.
Or we can use this one.
Huh?
This equation.
This equation is always perfect equation. Based on these equation, they have developed the tables. Okay. From where they got this table? This table is developed based on those equations. Okay. These equations are not coming from the sky. Based on those equations, because those equations at that time about 50 years ago, 60 years ago, because you are not having the calculators with this equation, all these things. So they develop these things in their design offices, because every day they have to do these things, solving this, bridge or that, all these things. So they develop this. Somebody was sitting in the office and say, okay, just with that. At that time also the calculation was not easy task. They were using log tables or this. Okay. Now it is very easy for you. You just take square root, you take sin theta, cos theta, very easy. So that's why they developed these things, and now the life was easy for them. So everybody just see, okay, take this value, and they were just sometimes taking approximate because this is nearly 40%. Okay, they say, okay, 40% difference from there. Same like the slope. Okay. The slope is reducing by this 40%. Okay, take the percentage of that slope and reduce the value in the same ratio. Okay, so now I will give you one question similar to this.
No time, doctor.
Huh?
Here in this
Yeah, speed time.
minutes, I want to ask about this one.
5 minutes.
Huh?
5 minutes.
6 minutes. 6 seconds. Yeah.
Now we can use this equation directly without the table.
Huh? Yeah, without the table.
Yes.
These equations are without the table.
And you can stop there.
And you can stop here. Okay? That is just one alternate way if you want to use, maybe in your project, if somebody wants, you can use this table. Okay? But this is more accurate. Now, just look at this. Okay, I will take the same section, similar to what is available in your sheet here. Okay, let us say W14 by 32. Okay, W14 by 32. W14 by 32 is the section. W14 by 32, and so this is W14 by 32. I am keeping the same steel grade and length, okay, maybe 18 feet. If you want, or if you don't want, keep 20. No problem. Keep 20 because you don't have time. Keep 20. Same. Only steel grade is, only this section is changed. 14 by 32. So this value will be same. On the value of R minimum, you will see from the data sheet how much for this section. W14 by 32, minimum value of R. W14 by 32, minimum value of R, you will see from here, R minimum, either this 3.76 or 6.28, so minimum is 3.76. Okay? Minimum 3.76. And Rx 6.28, so minimum value is 3.76. So we have got 3.76. R minimum is 3.76. Then you can calculate KL by R. How much is this value? Calculate 240 upon 3.76.
There is no 14 multiplied by 32.
Huh?
There is no 14.
No, 132, sorry, not 132. 132. Yes. W14 by 130. The first one?
Yes, first.
Yeah. W14 by 130. Huh? Okay. So KL by R, how much now? Yes. KL by R, tell me the value. KL by R. Yes.
63. 63.
63. Okay.
0.8.
0.8. This is less than 200. Okay. Now calculate pi square E over KL by R square. So you will substitute here KL by R, which is 63.8 square, and this value how much? Hmm?
70.382.
Yes, 70.32.
70.32? Correct? Pi square.
Yes, boys.
Pi square E over L by R square.
Yes.
Huh? Okay. 70.32. Now, what you will do? You will check 0.44 Fy. 0.44 Fy will be how much? 15.84. Now you check whether your Fe value is greater than 0.44 Fy.
Right.
Greater. So you will use equation 3.2.
Yes.
Right?
Same equation.
So we go to equation 3.2, 0.658, and Fy is 36. So here will be 36 upon Fe. Fe is 70.32. So this is 70.32 multiplied by steel grade 36. How much?
29.1.
29 point. 1?
Yes.
So this whole thing will be 29.1 KSI. Okay. So now, and you can see here, the slenderness ratio has decreased. Earlier it was 96.77. Now slenderness ratio is only 63.8, and see this value is increasing. So you get 29.1 KSI. Now you can calculate 5 CPN 0.9, FCR is this much, and gross area from the table, how much? Yusuf? Gross area here. Yes? How much? 38.8. So gross area is 38.8. A is equal to 38.8. We'll substitute here. 38.8, and this gives you how much? And this is 29.1.
Because should we satisfy that KL by R
Yeah,
is
it
like
should be
20?
less than 200.
What if it's more? What more?
Huh?
What if it is more?
If it is more, then you have to deal with long.
The general
columns.
formula.
Yes, long column.
Mm.
Yes. Okay. So here you have 433 point, how much? 29.1 into 38.8.
1060. Wait.
1000.
Yes, 0186.
10.
16.
Point 17.
No, correct. 1000
1060.
yes, 1016.
1016.
Yes.
Yes.
1061.
Yes.
Yes.
Point 70.
Kilopounds.
0.17.
Hmm?
0.17.
0.17. 1016.17 kilopounds. So you see here, just by reducing here, you see this value, this slenderness ratio is less. It's reduced from here. And the strength was, earlier it was 433 kilopound, now you are able to take more on that column. So that is one important point. That okay, so we finished in time. Now who came late? Yes. Yes. Abdul Mohsin? Late?
Yes.
Okay. Muhammad Atafi?
Yes.
Okay.